Hello friends, myself Raisa Sheikh, student of SRB Techs Mechanical from RIT Slampur. Today I am going to share a presentation on manufacturing process of spur gear. So let's get started. First of all, the manufacturing process of spur gear. Then see the introduction. In introduction, we learn what is spur gear. Spur gear means wheel with teeth projecting parallel to the wheel is axis. Spur gear are most easily visualized common gear that transmit motion between two parallel and coplanar and teeth that are straight and parallel to the shafts. Spur gear are one of the most popular types of precision cylinder. Then we can see the function of spur gear. In function, we learn spur gear are used to transfer motion and power from one shaft to another. Then next one is types of spur gear. There are mainly two types of spur gear. First of all is external gear and second one is internal gear. External gear means gear with tip cut outside the cylinder, two external gear mesh and rotate in opposite direction. And second one is internal gears. Internal gears means gears with tip cut on the inside of cylinder and external gears side in the internal gear. The gears rotate in the same direction. Because the shafts are closer together, internal gear assemblies are more compact than the external gear assemblies. Internal gears are mainly used for planetary gears. Then next one is process of flowchart. First one is selection of raw material. In raw material, mild steel is a metal alloy used in a casting of spur gear. Then selection of furnace. Then third one is pan preparation. Fourth one is core making. Fifth one is mold making. Sixth one is pouring. And then casting shake out. Then cleaning and inspection. And last one is finishing. In selection of raw material, we will see grey cast iron, nodular and ductile cast iron, carbonizing steel, nitride steel, bronze, non-metal as a plastic reinforced laminates, noiseless operation cheaper. First process is casting process in its simplest form. Casting process means casting involves starting with pattern of given engineering component such as gear, preparing a refractory mold containing this pattern, removing the pattern from mold and filing the resultant cavity with molten metal and allowing it to solidify into the shape of the engineering component. Then, at each step, depend on the one preceding it as well as one succeeding it. This column will discuss each one of them, particularly from standpoint of the design engineer, showing where he play an important role in determining the ultimate success of casting. Then, the element of casting design as related to foundry practice will also be discussed in some detail. Casting process have been used to produce gear blank or cast tools. Gear including sand casting, shell molding, permanent cold casting, centrifugal casting, investment casting, and die casting. Cut gears have also been produced from continuously cast bars. Next one is pattern making. This is the picture of pattern making. What is pattern making? The pattern is essentially a replica of the object about to cast, usually made out of the wood metal or model board. Patterns are used to create cavities in mold. It is though pouring molten metal into these molds that aluminum casting are created. The third process is core making. In this picture, we see this one is the core and this one is the pattern. Core making is a process which forms the internal part of the casting. The mold provides a space for molten metal to go, while the core keeps the metal from filling the entire space. Cores can be used to extend mold projection is to create extra mold selection or to block out and create a negative drafts. The next process is molding process. In this video we see how the molding process is actually work. Molding is a nothing but the mold preparation activity. For receiving molten metal, molding usually involves preparation consolidated sand mold around the pattern held within a supporting metal frame. Second is removing the pattern to leave mold cavity with course. Mold cavity is a primary cavity. The mold cavity contains the liquid metal and it acts as negative of the desired product. The mold also contains secondary cavities for pouring and channeling liquid material to primary cavity and will act as a reservoir if required. This is the picture of sand molding. Sand molding is best for large components with thick sections. This process is capable of making fairly complex shapes using relatively inexpensive wood patterns. This itself may have been made using a pattern or model of the final project. Then next one is melting and pouring. This is the picture of melting and pouring. In melting and pouring, when manufacturing by metal casting, pouring refers to the process by which molten metal is delivered into the mold. It involves its flow through gating system and into main cavity. Its resultant contents are poured into the ladle from which then it transferred into the thin molding hot furnace. Its resultant contents are poured into the middle from which it is then transferred. Once metal cools and solidifies, an iron casting is born. And then the next process is casting shakeout. In this picture, we see the casting shakeout. The separation of casting and sand is almost always done an unbreaking motion. Shakeout conveyors are used to shake off and segregate sand from casting and to crush the sand lumps without damaging the casting. After casting checkout process, next one is cleaning and inspection. In cleaning involves removal of sand, scale and excess metal from casting burn. All sand and scales are removed to improve the surface appearance of the casting. Excess metal in the form of fines, wires, sparking lines, fines and gates is removed. Inspection of casting for defects and general quality is performed. Then the last one is finishing process. Metal can sometimes fill in cracks in a casting mold or spurs. Pouring channel pour the mold and manufacturing must often finish the mold. Following casting, this can be accomplished through variety of finishing techniques including sanding, grinding, buffing. Once proper appearance and surface texture has been achieved, further post-treatment process such as painting or electropainting may be necessary for some applications. Then last one is outcomes of manufacturing of spur gear process. The spur gear is the least expensive of all gears to manufacture and is most common use. It can be manufactured to close tolerance and is used to connect parallel shafts that rotate in opposite directions. It gives excellent results at moderate peripheral speeds and whose load produces no actual thrust because contact is simultaneous across the entire width of the machine tip. It tends to be the noisy at high speed. However, noise wear is minimized with proper lubricants. Thank you, friends.